let's solve some problems on Fourier's expansion. Let us expand that is, uh, that is f of x. Okay, so the function which is f of x given by f of x, which is minus k and k for the interval minus pi to pi, where k is greater than 0 and is a constant in a Fourier series over the interval minus pi to pi. Okay, and also we have to deduce pi by 4 as 1 minus 1 by 3, 1 by 5, and minus 1 by 7, and so on. Okay, so let us solve that. Now, first, the given function, whether it's an odd function or even function, let us check that. Okay, suppose we put f of minus x here, right? Now, if you look at that, the interval changes, right? So this is minus k, and this is k. Now, for minus pi less than minus x less than 0, and this is for 0 less than minus x less than pi. Now, this would be 0 less than x less than pi, and this is minus this would be minus pi less than x less than 0. Okay, now if you look at this, this is of negative of f of x, right? Therefore the given function is an odd function. Okay, so this is an odd function over the interval minus pi to pi. Okay, now we know, we got that the function which is an odd function. So we have the function which is f of x summation n is equal to 1 to infinity bn sine nx. Okay, now let us find what is bn. Bn is 2 by pi integral 0 to pi, right, f of x sine nx dx, right? So now we have over the interval minus 2 pi 0 to pi, which is k. So 2 by pi integral 0 to pi, this is k sine nx dx. Okay. Now let us integrate this. So this will be 2k by pi, taking out the constants, which is k, and integral of sine nx will be minus cos nx by n over the interval that is 0 to pi. Okay, again by substituting the interval x as 0 and pi, so this will be 2k by pi n. Okay, so this will be 1 minus cos n pi. Okay, now for n as even and for n as odd, we get the results as 0 when n is even, right, and it is 4k by n pi for odd n. Okay, so we got what is bn. Let us now substitute in this, okay, which we have taken as um, equation 1. Okay, so henceforth the function f of x is summation. Now this will be for n is equal to 1, 3, 5 and so on. Okay, for k by n pi, right, sine n x. Now let us substitute for n is equal to 1, 3, 5 and so on. So this will be 4k by pi, and this will be sine x plus 1 by 3 sine 3x plus 1 by 5 sine 5x plus 1 by 7 sine 7x. Okay, and so on. Let us keep this as 2. Okay, now this is what we get as a required expansion of the function, which is f of x. Now we got to deduce that pi by 4 as 1 minus 1 by 3 plus 1 by 5 and so on. So let us substitute x as pi by 2. Okay, now for x as pi by 2. So we have f of x, which is k. Okay, so on the left hand side you have k as 4k by pi, right? And now this will be sine pi by 2 plus 1 by 3 sine 3 pi by 2 and 1 by 5 sine 5 pi by 2 and 1 by 7 sine 7 pi by 2 and so on, right? Now you can see, you can cancel out k and k. So this would result the final result, which is pi by 4, which is 1 minus 1 by 3, 1 by 5 minus 1 by 7 and so on. Okay. Now let us look at another problem now, where the function which is root of 1 minus cos x. Okay, let us expand the function which is f of x root of 1 minus cos x, right? In a Fourier series, right, over the interval which is minus pi to pi. Okay, now let us solve this. Now let us check whether it is an even function or odd function. So given function which is f of x, this is 1 minus cos x. So f of minus x is square root of 1 minus cos of minus x, which is again 1 minus cos x. Again, this is the function which is f of x. So hence this is an even function over the interval minus pi to pi. Okay, now since it is an even function, now f of x will be a naught by 2 plus a summation n is equal to 1 to infinity an cos nx. Okay, now a naught is 2 by pi integral 0 to pi. This is f of x dx, right? So your function which is which is square root of 1 minus cos x, right, dx. Okay, which can be written as 0 to pi. This will be square root of, this is 2 sine square, okay, of x by 2, okay, dx. Yeah, now now this will be 2 root 2 pi 0 to pi, okay, this is sine x by 2, right, dx. Now t is x by 2, right? Let us substitute that. Okay, so this would be, this will be 4 root 2 by pi 0 to pi by 2, because we have considered t as pi by 2, right? So this is sine t into dt. Okay, now this would be after substituting the values, right, intervals, so we get 4 root 2 by pi. This is what you get for a naught. Okay, further let us find what is a n here, right? So this is 2 by pi integral 0 to pi f of x cos nx dx. Okay, so this is 2 by pi integral 0 to pi f of x is root 1 minus cos x, right? This is cos nx dx. So again, once again, 2 by pi, this is 0 to pi, so this is square root of 2 sine square x by 2. Okay, this is cos nx dx. So this is 2 root 2 by pi integral 0 to pi sine x by 2 cos nx by nx dx. Okay, now this is the form sine of sine a cos b. Okay, let us substitute those, right? And this is square root 2 by pi integral 0 to pi. This will be sine of n plus 1 by 2 into x minus sine of n minus 1 by 2 into x dx. Okay, so this is square root of 2 by pi. This is minus cos of n plus 1 by 2 into x by n plus 1 by 2, right? Integration of sine x, and this is plus cos n minus 1 by 2 into x by n minus 1 by 2, right, over the interval 0 to pi. Okay, okay, now let us substitute x as pi and 0. So this will be square root 2 by pi. This is minus cos n plus 1 by 2 into pi minus 1 divided by n plus 1 by 2, right? And this is plus cos of n minus 1 by 2 to pi minus 1 divided by, this is n minus 1 by 2. Okay, further, uh, we know the results of cos n pi and cos pi by 2, which results to 0. Okay, for cos of n plus 1 plus or minus 1 by 2 pi. Okay, so this would be uh, square root of 2 by pi. This is 1 by n plus 1 by 2 minus 1 by n minus 1 by 2. Okay, so after simplifying this is root 2 by pi, and this would be minus 1 by n squared minus 1 by 4. Okay, which results to minus 4 root 2 by pi into 4n squared minus 1. Okay, so we got the result for a naught and an. Now let us substitute this finally. So this would be the function which is f of x, which is root of 1 minus cos x. Okay, so this will be 2 root 2 by pi minus 4 root 2 by pi summation n is equal to 1 to infinity. This is cos nx by 4n squared minus 1. So we got the results. That is for the function f of x square root of 1 minus cos x. I hope you enjoyed the session.